That's recorded.
All right, so probability part 3. Anything you have a question about? Let's take a look at it. Yep.
12B.
12B. And I want you to really pay attention to the wording, because every year I kind of struggle to rethink the best way to ask this without being like overly wordy. So make sure if you understand the wording that's on this, it's going to be a similar, if not exact wording on the test. So I'm sorry, one more time.
12B.
12B. Okay, so number 12B, it says what would be considered more difficult to get. So technically you have to find the probabilities of both, and technically you would have to punch these in your calculator as well. And then how would you know which one, which I'm probably not going to do on your test because I don't really want you to focus on typing it in your calculator. But ultimately, which one would be the hardest to get? The one that has the least probability, right? The smallest probability. So without focusing on that, I want you to find the probability of getting a queen high straight. And if you get a queen high straight, that means, in case you don't know what a straight is, which is okay, if I ask that question again, you'll have seen it. It means that you're going to have a 5 cards in a sequence. A straight doesn't have to have the same suit. So you could have something like a queen, a jack, a 10, a 9, and an 8. You have to have those 5 cards, but it wouldn't matter if they're all hearts. You could have hearts or clubs or whatever out of them. And obviously, since the order in which you receive them does not affect the outcome, it doesn't really matter that you pick them in that order, right? As long as you end up with them at the very end. So bottom line is you need these 5 kinds of cards, right? Not just any 5 kinds, you need those. So, and you need 1 of each, right? So how do you figure out how to get 1 queen? You've got to count the total number of ways that could happen. So 4C1, right? Now you could also just say 4 in this case, because there were only 4C1 does end up being 4, but either one of those, 4C1 and then the jack. Again, a 4C1. Now if you see you're going to do 4C1 5 times, what could you just do? 4C1 to the 5th, save yourself a little bit of time once you see that. And then, of course, there's 5 cards you're picking from the 52 in the deck. So you could just do that. You could say, because 4C1 is 4, you could say 4 to the 5th, 1024, whatever, anything you want in that regard. But be careful, because if I alter this question a little bit, like what if I said you're playing 10 card poker, right? So you're drawing 10 cards. And I say that I want you to have 2 queen high straights. Now, if I say 2 queen high straights, that means you need 2 queens, 2 jacks, 2 10s, 2 9s, and 2 8s. And the mistake people make, a lot of times people who are thinking like this, when they're counting up 1 queen, 1 jack, 1 10, 1 9, the mistake people make is they go, okay, well now if I need 2 queens, they go 4 times 3. And if I need 2 jacks, they go 4 times 3. And they count this way. Now, can anybody tell me what's wrong with that? What would be wrong with this, saying, hey, I'm picking 2 of the queens, 2 of the jacks, 2 of the 10s, 2 of the 9s, 2 of the 8s? Why is that wrong if I do that? That's right. See, 4 times 3 is suggesting that the order in which I pick them, 4-3 is the same thing as 4P2. It's the first 2 numbers in 4 factorial. That's 4P2. What's that suggesting is you picking a queen of hearts and then a queen of diamonds is different than picking a queen of diamonds and then a queen of hearts. But you know that's the same 2 cards, right? So what you want to do is say, hey, I'm going to pick 2 queens from the 4. Well, that's 4C2. And 4C2 is not 4 times 3. So getting in the habit of writing 4C1 when you're picking from the 4 really helps you instead of just kind of saying 4, it really helps you when it gets to a more complicated problem where you're picking more than one. And when you do that, the 4C2 already accounts for that. 4C2, if you remember the math of it, 4C2 says 4 factorial divided by the difference. That's 4/3 right there. But then it also divides by another 2 factorial. And that extra 2 factorial takes care of, basically it does that on each of these. That extra 2 factorial divides away all of that repetition where you're overcounting. It says, oh, they've overcounted because just this part is the 4 times 3. But making it a combination instead of a permutation divides out that repetition, and that gets you back to where you want to be if the order has no effect. Are y'all seeing that? What else? Anything on this probability part 3? Yeah.
Number 5.
Number 5 says, what's the probability that in a game of straight 5-card poker that I'm dealt exactly 3 kings and a pair? And they don't specify what the pair is, right? But they do specify that you have to get 3 kings. So if I'm going to get exactly 3 kings, I have to pick those 3 kings from the what? Like, think about it. All the cards are faced up on a table. I say, walk over here and pick any 3 kings. Are you focused on all 52 cards? Or are you focused on just the kings, right? So if you're picking 3 kings, you're going to pick them from the 4. If you're counting the number of ways to do that, right? So you're saying 4 kings, I'm going to choose 3 of them, and then the kings are off the table. Now, if I'm picking a pair, now I've got some options, right? So how many different ways can I pick a pair of cards? A pair means a kind, right? Not 2 hearts. A pair would mean, in case you didn't know that, pairs are not like 2 hearts or 2 diamonds or 2 clubs. Pairs would be like 2 tens or 2 queens or 2 jacks. So how many different kinds are left for you to pick from? Now there's just 12, right? I can't get, oh, and by the way, let me specify this. Even if I had said 2 kings and a pair, if I said that and you went 4C2, you don't want to get your pair from the kings. Are you with me on that? Because if I got another pair of kings, do I really have 2 kings and a pair? No, I would have what we call 4 of a kind, right? If you have 2 pairs of, I mean, that's fun. I don't know if you've ever played poker before. I mean, it's rare that you get dealt 4 of a kind, but when you do, I don't know why I always do this. If I'm playing and let's say I have 4 kings and I'm betting, of course I'm starting to ease the bets up and suck more of my friends' money out on the table. And then at some point they go, oh, what do you got? And I'm like, man, all I got is these 2 pairs. Pair of kings, and I throw them down on them. It's always kind of fun to kind of, or throw out just I got 2 pairs, and you see them start to reach, and you're like, oh, kings, and just kind of, anyway, it's a little bit more fun when you can talk some trash, but whatever. But make sure if I say 2 pairs, I don't mean a pair of one and a pair of that same kind, because that wouldn't be 2 pairs in poker, right? Even though you might have fun with that, it would really be 4 of a kind. So yes, if I can't pick kings anymore and I want a separate pair, that would mean that there's only 12 kinds left to choose from, right? So how many of those kinds are you going to pick? 1. So you're going to pick the kind, 12C1, and then once you pick that kind, I don't know what it's going to be. Might be queens, might be jacks, might be tens, might be sevens. How many do you need from that kind? 2 of those 4. So you'd say 4C2. Are you saying this? You're seeing it? So this is picking 3 of a kind. This is picking 2 of a kind. But here, you are told to pick kings. You could have said 1C1 to pick the king, because there's 1 set of kings and you're going to pick it. But there's 12 kinds you could pick from now. But why didn't I say 13C1 to start? Because it told you to have kings. Now, what if it didn't say to pick kings? What if I said, I want you to pick 3 of a kind, 3 of a kind, and then a pair? Well, if I said that, I said, hey, pick 3 of a kind. Well, you got to decide which kind is it. How many different ways could I get that 3 of a kind? 13C1. How many, and then you pick 4C3. Once you decide which kind it is, pick 3 of that kind. And then you come over here, right? And you have 12 kinds left, 12C1. And then once you count up all the different ways you can do that, 2 of those kinds, of that kind. And if you're wondering what we were talking about Friday at the end of the day, what if I said, what's the probability of getting 3 of a kind, and another 3 of a kind? Well, in that case, what's special about this one? You got the same number of each kind. So when you go to pick the kinds, you do not say 13C1 and then pick your 3 of a kind, and then go 12C1 and then pick your 3 of a kind. You don't do this. That's bad. And the reason why you don't is this is suggesting that, for instance, 3 queens and 3 kings is different than 3 queens and 3 kings. And the reason why, even though you might not think that, what does 13C1 leave me? What does it give me? What is it equal to? 13. And what's 12C1 equal to? 12. And what's 13 times 12 the same as? 13P2, which means you just said, even though you're like, no, I didn't, I used C's. I know you think you said it, but 13 times 12, which is that times that, is saying 13P2, which is saying the order in which you pick those kinds has an effect on the outcome. No, it doesn't. 3 queens, 3 kings, 3 kings, 3 queens. It's the same hand, right? Right? So what you would have to do is say, no, in this case, because it's the same number of each, and I don't know which kinds they are, I've got to go, all right, there's 13 kinds. I'm going to pick 2 of those. And then and that shows all the different numbers of ways that you could pick the kinds. And then within those kinds, I'm going to pick 3 of one, 3 of another. And this would go with both. And the only time you do that for both is when you have the same number of each that have to be chosen. Otherwise, you do a separate combination for each one. And then don't forget, of course, to divide 52C6. But that's for this modified problem in this thing. Are y'all seeing that? If you can get that down over the next couple days, you're going to be in pretty good shape, because honestly, that is the most missed thing on this test. But it probably is the most missed thing because it's the least covered thing, and I normally don't have a 3-day review on this. Normally, you're relying on a lot of what you learned from before, and we do a 4-day probability review test. But you're learning it all at once, so it probably is going to be a little fresher for you guys, a little bit more reviewed for you guys than in years past. Or I would hope anyway. What else? Any question on here? Yeah.
We do 11.
Yes. What's the probability I'm dealt a pair in a game of straight 7-card poker? Oh, I'm not dealt a pair. Okay, so what does not getting a pair mean? That the 7 cards you pick will not be from the same kind. So you're going to have 7 different kinds. Is that what that's saying? Okay, so basically this is the same thing as me saying, hey, you're going to get 7 cards that are 7 different kinds. So 1 of one kind, 1 of one kind, 1 of one kind, 1 of one kind. Well, that sounds like the same number of a bunch, right? Now, I didn't specify which kinds there were. If I specified, hey, I want you to have a 2, I want you to have a 7, I want you to have a 10. If I did that, you're going to say 2, 7, 10. You would do this 7 different times, or say to the 7th, right? You would say that if I told you which kinds to get, but I didn't tell you. So how many different ways can you get 7 kinds from the 13 kinds? 13C7. So literally that was like we were talking about here with the 2 of one kind, and you would have said 13C2 on that modified example I did. This is saying, hey, I don't know how many. They're the same number of each. So this arranges or counts all the different variations of kinds that I could get. But that's just the kinds. And then within each kind, of course, there's different ways to pick those kinds of cards. And then, of course, 52, 52, C7. But if it were me, I would just write this. Save myself the trouble. Say that to the 7th. But why don't you want to do this? Why don't you want to go, well, there's 13 ways to get the first one, and then 12 ways to get the second one, and then 11 ways to get the third one. Why don't you want to say that? Or even there's 13C1 ways to get that, 12C1 ways to get that. Why do you not want to do that? Because that's like saying 13, 12, 11. That's like saying 13 what? P7. So if I write it 13, 12, 11 like this, or even if I said 13C1, 4C1, 12C1, 4C1, even if I said, even if I say that 13, 12, 11 is like saying 13P7, and I didn't even see it coming. It snuck right up on me. And 13P7 would be suggesting what? That the order in which you picked those 7 kinds or decided or counted the number of ways you get 7 kinds, the order in which you did it would have an effect on the outcome. That's overcounting. That's counting ways like kings, jacks, tens, the same as tens, jacks, queens. No, they're not. I mean, it's the same, but it's counting them like they're different. You don't want to do that. You want to use a C to say, hey, the order in which I do that does not affect the outcome. And again, that's one of the trickier things out there to remember. All right. What else? Yep. Yes. So, game of 5 card poker says this is slightly different than the one I did in what was it, number 5? Number 5 said I'm basically getting a full house, but it specified a king, right? Number 7 says I'm getting a full house, but it doesn't specify 3 kings. It says just 3 of one kind, 2 of another. Now, what's wrong with doing this? Well, there's 13 kinds. I don't know which kinds I'm going to use, so I'm going to say 13C2 to talk about how many ways I could do the kinds. And then once those kinds are decided, I'm going to pick 3 of one and 2 of another. So tell me, what is bad about that in this problem?
They're not the same number.
It's not the same number. And if that's bothering you still, why? Think about this. If I count, say I'm counting 3 queens and 2 jacks. That's one of the situations this would count, right? It's saying I'm picking jacks and kings. But queens and jacks, 3 of these and 2 of those, because again, this is only saying, hey, queens, jacks. It's counting all those different ways. And it's saying queens, jacks, jacks, queens. It's saying that by using 13C2, it's saying that this is equal to that. Well, it would be if I had the same number of each. 3 queens, 3 jacks, 3 jacks, 3 queens. That's the same thing. I would not want to overcount. That would be great if I had 3 of each. But 3 queens, 2 jacks, and 3 jacks and 2 queens, that's different, right? So in this case, I don't want to count those at the same time because that's not going to count the differences, and that is different. So in this case, I'm like, wait a minute, because there's different numbers of these, I don't know them, because there's different numbers, I want to do what? Pick the 3 of a kind, and there are 13 kinds to choose from. You're going to pick one of them, right? So there's 13 different ways you could do it, but within each one of those 3 of a kinds, 4C3. And then once you pick that kind, then there's what? 12 kinds left, 12C1. And then once you pick that kind, there's going to be 4C2 ways to do that. And this would just go with that one, and this would go with that one, basically. But you would be making a mistake if you said 13C2. Why? Because again, 13C2 is saying, hey, the order in which you pick them doesn't matter. Queens, jacks, jacks, queens. But wait, queens, jacks, jacks, queens, that is different. So do it separately.
And couldn't you just say 13P2?
Say it again?
Couldn't you just say 13P2?
You could say 13P2 because 13P2 right here means the first two numbers in 13 factorial, right? And 13P2 is that. 13C1 is the same thing as 13. 12C1 is the same thing as 12. So yeah, you could get away with that completely. What else? Anything on here? Seems like there's one or two on there that nobody's talked about that I want to throw today. Everybody else felt good about it?
10.
Number 10.
Okay, what is the probability in the game of straight 7-card poker? And straight poker is like different than draw poker. I'm just throwing words out there, but I won't use different stuff. There's draw poker where like I give you a card and you're like, I give you 5 or 7 cards, whatever, and you're like, all right, I don't like 3 of these. You give them back to the guy, and then he'll give you 3 more. And you get one draw like that, typically. And everybody has the option of taking anywhere from 2 to 7 cards or whatever, if you're playing 7-card. Most people don't play 7-card draws. It's 5-card draw is a more common game that you'll see in Vegas. I don't find it very fun, honestly. There's not as much drama in it. It's more of an old school poker game. But anyway, but straight poker just means those are the only 7 cards you get. Okay, don't confuse that with getting a straight, which would be consecutive cards in order, like 2, 3, 4, 5, 6, or whatever. But again, if you understand these, I'm not going to sneak any obscure rule on you when it comes to the test. I'm pretty straightforward. In my memory, I have nobody who's ever come to me after the test who's done the work and said, man, I didn't know what that hand was. Because every time I ask you a question, it's been on these review sheets multiple times. So if you're confused a little bit about it now, just remember this situation for the test and you'll be fine. Because usually that is not, always that's not been the case. You said 10. So I'm dealt a flush. So a flush is not when you get a bunch of one kind. A flush is when you get 5 of one suit. Okay? So I don't know if you've ever seen Ocean's 11. Y'all seen Ocean's 11? Well, there's a part at the very beginning of the movie where Brad Pitt, he's kind of a con artist, whatever. It's a pretty good movie, actually. But he's kind of this con man, whatever, burglar. And he's just kind of, when his friend went off to prison and he's kind of doesn't have his partner anymore. So he's been like teaching celebrities how to play poker. And one of the first scenes in there, he's sitting there with like real life celebrities playing themselves. And he's showing them how to actually play a game of cards. And they're so bad. And I don't know if you know who Topher Grace is. Anyway, well, he's in the role. He's in one of the characters. And at the end of the hand, he's trying to show them what to do. And he goes, all right, the betting's over. All right, put your cards down. This guy goes, like, if you play poker, you know this is funny. He goes, all red. And he puts down these 5 red cards, like a couple diamonds, 3 hearts, which is a crap hand. It means absolutely nothing. And he's like high-fiving his friends. It's kind of funny if you play poker and you've seen that scene. But anyway, a flush is not all red. Okay, so it's like all diamonds or all clubs or all spades or all hearts. So, but here's the thing. You only need 5. So when you play 7-card poker, if you have 7 hearts, you have a flush, but you're only going to play your best 5. So you would play of the 7 hearts that you have, you pick the 5 that are the highest, like maybe the ace and the king and the queen and the 10 and the 7, as opposed to the queen and the 10 and the 7 and the 3 and the 2 or whatever. You would want the lowest because you want to build the best, highest ranked hand you have. Okay, so if I say you're going to get a flush, notice I wrote there at least 5 of the 7 cards would be diamonds. All right, so I'm specifying diamonds, so you don't have to pick which kind of suit. I'm telling you that. So you don't have to go, well, there's 4 suits, I'm picking one. So you don't have to do the 4C1, I'm telling you it's diamonds. But within those diamonds, when I say at least, what does that mean? I could build this flush with 5 diamonds or 6 diamonds or 7. So it sounds like you have 3 probabilities you have to calculate. And by the way, it's a 7-card hand. So if I pick 5 diamonds, I also have to count the number of ways that could happen with the other 2 cards because they're still getting picked, right? And those other 2 cards, if I have exactly 5 diamonds, can't be what? Diamonds. And then I have to say, all right, now I have 6 diamonds. But I still have that other card. What's that other card have to be? Not diamonds. And then the last one, 7 diamonds, so I don't have to worry about any other cards because there weren't any. And because I could do it 5 or 6 or 7, what do I put in the middle of each of these probabilities? A plus. Okay? So let's check it out. I'm going to do 5 diamonds first. So on this, they've already picked diamonds for me. So how many diamonds are there? 13. So of the 13 diamonds, I have to pick any 5. But it says I'm picking 7 cards. So I'm picking 5 of the diamonds and 2 of the what? Of the non-diamonds. Now, don't make this mistake. Don't say, but wait a minute. If you only pick 5 cards and there's 52 cards, there's 47 cards left. Why is this bad?
Because it could be wrong.
That's right, because there's some diamonds left in there. And if I just pick 2 of the remaining 47, I mean, think about it. Imagine all the cards face up and I pull 5 of the diamonds out. So there's still 8 of them floating around in there. And I say, pick any other 2. Isn't there a chance that you could pick an extra diamond? Well, I don't want to count that here because I'm only counting the 5 ways. Are y'all seeing that? So that's wrong. I got to say, hey, there's only 39 other cards that are not diamonds. The clubs, the spades, the hearts. It's 39. Then I go, or I could do what? 6 of the 13 diamonds. But if I pick 6 of the 13 diamonds, I only need what? 1 of the remaining 39, 39C1. And since 39C1 is 39, you can get away with putting a 39 there. Technically, 39P1 is also 39. As long as the math is right, I'm okay. Or what? All 7 of them from there. And if you wanted to be, you don't have to put anything else. I probably wouldn't put anything else. But technically, you could say times 39C0, none of the other 39. And it would kind of look consistent. But 39C0 is equal to 1 when you do the math. So it doesn't change anything. And then, of course, you have 7 cards you're choosing from. Y'all track with me? Does anybody, like, in your head right now feel like what you did was different than this, but you feel really confident about it? And if you want to share it with me, I can probably point out the fallacy in the thinking that might help reinforce. Does anybody have something like that where I'm showing you one way and you're like, okay, fine, that makes sense, but why won't my way work? And you're wondering why? Because sometimes you might not be thinking about a certain situation and I could go, hey, this is what you're saying, this is what it means. Sometimes it's hard for me to do that. Like sometimes I look at it and I'm like, I hear what you're saying. I know this is right. We actually type in the calculator. My value will be right, and I know it's right because I've Wolfram alpha checked all these things. And then sometimes it's really hard on really complex stuff to see why it's wrong. But normally I'm pretty sure I can with all my problems if you've done something different. What else?
So on the test, are you gonna have like the little definitions, like that at least 5 of the 7 cards?
I usually do, or it looks exactly like it did on your sheet. But again, I have no memory of anybody coming up to me and going, what does this mean? So evidently, they've got enough practice on this where the problems I've picked in the past haven't been so obscure. They're like, oh yeah, we've done stuff like that. So they feel confident. Like I don't have people walking up and going, is this, I don't know if you mean if this is dependent or independent. And I'm like, well, if they have asked me that, I've said, well, we had that problem like 10 times. You know, you should know at this point. Like if you walked up and said, hey, is drawing cards dependent or independent? Well, you haven't done any homework, right? Because we've been looking at these as what this whole time? Dependent situations, right? Now, if I did say independent, this becomes significantly uglier, right? Now, what if I don't specify that? Oh, and by the way, could I have done this? 52C7, 52C7. And if you did this, that's fine. I just thought it was easier since all the denominators were going to end up. Then I have to choose the suit, right? And how would you choose the suit? You could just say times 4 in this case, since you're only picking one suit. Or you could, with each one of these, say 4C1. Or if you really want to, you could say, hey, 4C1, I'm picking the suit first. This is if I didn't say diamonds, right? If I just said A flush, well, there's lots of ways to do flushes, even under these circumstances. So there's 4C1 flushes, and then once you pick that, 4C1 suits, once you pick the suit, right, or count the number of ways you can do the suits, then within each suit you have this. And again, you could put that 4C1 with each one if you wanted to, which is what distributed property would have done. What else? Did y'all see the wording on number 6? This is what I was really kind of referring to earlier. I don't think we've talked about 6, but it says, what's the probability in a game of straight 5-card poker that I'm dealt exactly a full, no, that's not the one. Number 6, sorry. What is the probability that in a game of straight 5-card poker that I'm dealt exactly 3 of a kind and 2 other different kinds? What do I mean by 2 other different kinds? If the other 2 cards are what? Don't just say different, because every card in the deck is different. They're not pairs, right? So, and they don't match this other. 2 other suggests they're not the same as this kind, right? And they don't match each other in kinds also. So like, for instance, if you're 3 of a kind, or you decided that was a queen, right? That would mean these 2 other different kinds would be like jacks, 10s, not jack, jack. Because if it was jack, jack, we wouldn't say it was 2 other different kinds. We would say it's a pair. Are y'all with me? Now, I could say that like, hey, and the other 2 cards are not pairs, or don't form a pair. I could say that too. But I'm saying this is usually how I word it on my tests. So if this was the case, what is wrong with me doing this? Well, I'm going to end up with 3 different kinds, right? Because I haven't specified what kinds I'm getting. What's wrong with me saying 13C3 and deciding the kinds first like this? Because say 3 jacks and a king and a 10 would be different than 3 queens, a jack and a 10, or 3 10s, a jack and a king, right? Those are actually different. So I would want to count those differently. But this is not doing that. This is not saying 13, 12, 11, or whatever. This is saying 13, 12, 11 over 3 factorial when you clean it all up. It's dividing away those ways that you could have got them differently, but they are different. So what do I want to do in this case? 13C1. So the first 3 of a kind, there's 13 ways to do it, and then pick 3 of those. Great. But wait, for the last 2, what would I do? Are y'all seeing 12C2? Because they are the same amount. So like once this kind's out of the way, say there's 12 kinds left. Is a jack and a 10 the same as a 10 and a jack? Yeah, so I don't want to overcount that. I don't want to say 12 ways to do this, or 12C1 ways to do this, and then 11C1 ways to do that. That's saying 12 times 11. That's 12P2. That's saying the order in which you get them has an effect on the outcome. No, jack, queen, queen, jack, that's the same when you have the same number. So in this case, I'm going to go 12C2. Why not 13C2?
Because you've already picked it.
Already picked a kind, right? So 12C2, and then now that you've decided which kinds, what am I doing? 4C1, 4C1. Y'all starting to get this? I'm telling you, if you do, you really are learning some advanced probability. Like this is not high school. I mean, it might be Vestavia high school probability, but it's not high school probability. I mean, I doubt. What you'll know is probably I could put you up against any teacher in the building. They don't know how to do this. It's just math team junk. So you're really going to know some probability. So if you ever go into a math team class, you're really going to have, if you get this, 52C5. You would really understand probability at a pretty decent level. Probably make you Probably get you through the first 3 or 4 weeks of a probability class, an intense probability class in college, I would think, at least. Maybe longer. Anybody else? I want you to be in a good place.
Can you do one of the problems, but like make it like replacement? Like,
Okay, so like this one. All right, so if I was doing replacement, immediately what can I not do? Okay, now I can still do combinations. I can still do a combination with choosing the kinds, right? Because I need like 3 of one kind, 2 other kinds. That, even though they'll still be available, I want them to be different, right? So I can still do that. But when it comes to counting the cards like this, you wouldn't be able to do this. Okay, so for instance, what I would have to do is say, okay, how many different kinds on the 3 of a kind could I get? And you could say, well, there's 13C1. But now when it comes to picking the 3 of a kind, I can't say 4C3 over 52C3 or whatever. I would have to go, okay, now what's the number of ways to do that? Now, I don't know that I would do it on a problem like this, because that's a little extra tricky. But if I did, how many ways can you get that first card of this kind that you told me about? Sorry, what is the probability if you were drawing independently that you would, like, say you had a queen, and you knew it was going to be a queen. What's the probability that it would be a queen? Probability it would be a queen on one card, 4 out of 52 or 1/13? Because there's 4 queens in the deck, right? But then you put it back. So what's the probability that the next one will be a queen? 4 out of 52. And the next one, 4 out of 52, right? All right, so I've counted up the ways to do the queens. Now what? You got to get the other 2 kinds. But the other 2 kinds, there's lots of ways to do that, right? So how many ways could you do it? 12, C2, because there's 1 of each. How many ways to get that first kind? Say it's not a queen. Say it's a jack that you pick. What about the next one?
Would you have to take off some of the 52?
Not if you're putting it back in. Because if you keep putting it back in, all 52 cards are available, aren't they?
isn't that saying it has to be a jack then?
Yeah.
Like, wouldn't it be like 47 of them?
Because it can't be the queen.
Now hold on. This is saying, like, play with me. Queen, 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 jack, 10. Okay? So if I had queen, 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 jack, 10, but I don't know that I have queens, right? So there's 13 different ways I could pick the queens, and then I do this. Are you with me? I'm not finished with this, by the way. And then there's 12C2 ways I could decide which of these other 2 kinds there are. But I keep putting them back. And if I keep putting them back, there's still 52 available. There's still 4 jacks. There's still 4 10s. There's still going to be 4 queens each time because I'm putting them back. And then what do? Did I specify that I had to go queen, 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 then jack, then 10? Now let me simplify it for you. What if I said I want 3 queens, a jack, and a 10? Isn't that what you would have done? Queen, queen, queen would be just this. Jack would be just this. 10 would be just this. Then you would multiply by this because I didn't specify that it had to be in that order, right? So this is what I would do normally on a replacement problem, and that probably looks a little familiar to you. But because I didn't specify that it had to be queens, I didn't. You have to come in here and say, well, there are 13 different kinds. I could have picked one. And then I didn't specify that it had to be jacks and 10s. So there are 12 left, and I can pick 2 of those because there's 1 of each, and I have to choose those at the same time. So the part that I'm underlining in brown, hopefully that's the part that looks semi-familiar to you. But this is the part that makes it really tricky, because this is what you'd have to do if I don't specify which kind you would have. And I would think this would be a really tricky problem on a test. Like that would be probably one of my top couple hardest problems if I were to do something like this. That doesn't feel to me like it's very common. That would be really tricky. But sometimes I do that. I throw a little problem out there, you know, separate the wheat from the chaff, see who's ready for game time. But I'm not going to give you a whole test of this kind of stuff. Good night. That would be awful, because if you didn't know one concept, you'd make a 50, right? I mean, look how similar this is. If I don't say replacement, let's just say I said queens, jacks, tens. So you knew that, and you weren't replacing it. Wouldn't you go 452, 351, 250 if you knew it was going to be queens and you weren't using combinations? And then if you knew it was going to be a jack, wouldn't you say 449? And if you knew it was going to be a 10, wouldn't you say 448? But then you go, wait, he didn't say in that order. So because I didn't say that, how many ways can you arrange these 5 letters if 3 of them are the same? You'd say 5 factorial over 3 factorial, 1 factorial, 1 factorial. That would probably seem more similar or common. Well, what's changed? I didn't say you had to have a queen. I said you had to have 3 of a kind. So what do? You jump in there and go, well, 13C1. I didn't say you had to have 1 jack and 1 10. So you come in there. Sorry, let me snuggle that up. So you come in here and you say, oh, 12C2. Well, that's the same thing, except if I say with replacement, you're not decreasing your numbers. They're always going back in there the same. So 52s are the same, 444 is the same. Right? But if I don't say replacement, you don't have to do them individual like that. You could do combinations all the way through.
So is our homework the worksheet that's not in the book?
Yes, I think this, and make sure you really look at the wording. I realize when you look at your review sheets, one of them says review probability and counting, one says probability and counting, one says probability, and then review probability. So be really careful about the words. So, and I don't care as long as you get them all 4 done at the end. But be careful about the wording if you want to have done the worksheet we're going to be discussing the next day. Oh, hey guys, one last thing. If you look at the very last day before the test, I put 2 reviews out there only because I had an extra one. And I felt like I'm not going to give another day of probability review. But I did 2 out there. I'm happy to answer any questions about stuff, no matter what. I'm just so if you want to work ahead and ask me a question, that's fine. It's your call. But we're really just going to be working in class the next couple days after today, unless you have particular questions.
But not the.
Appreciate it.